On to our next question. Determine whether they're polar or nonpolar. We begin with NH4. Our valence electrons are 5 plus 4 minus 1. That is going to leave us with 8 electrons. And so what that will look like is this. If we have single bonds between each of them, place the remaining valence electrons on the nitrogen because that's the only place it can go, leaving you with this. Double check your formal charges. On the nitrogen, we are going to have 5 minus 3 minus 2, 0. Sorry. 2 NH4 plus. My apologies. This is NH3. NH4 plus would have that extra hydrogen because there are 4 hydrogens, and we'd have no extra electrons on the nitrogen because we've accounted for all of them. And so nitrogen's formal charge will be 5 minus the 4 and the bonding pairs, leaving us with the +1. So the positive charge is on the nitrogen. Double check your hydrogen, and it's just going to be 1 minus 1, which is 0. This all makes sense. We expected a net charge of +1. And so this is our Lewis structure. From there, we get the steric number. And that is simply going to be equal to the number of bonding pairs, so 4, plus the number of lone pairs, which is 0. So it's 4. To notate that it's 4 bonding pairs and 0 lone pairs, it would be AX4. And so now when we come to the Vesper chart, we're going to look for it. We come to the steric number, and with 0 lone pairs, so it's tetrahedral in both its electron geometry and molecular geometry. So we can go about drawing that. Okay, and then we can see how the dipoles work out to determine whether it's polar or nonpolar. So nitrogen is of course more electronegative, so all of the dipoles will be pointing towards it. And so the angular components of these 3 are going to cancel due to the trigonal shape that's going on here. And so we're going to be left with a dipole pointing inwards and an equal dipole pointing upwards, because you're only left with you're only going to be left with the vertical component of these 3. And so these 2 are going to cancel, leaving you with a non-polar molecule, because that is equal to a 0 net dipole moment. And so our first one is nonpolar. On to the next one. Let's count our valence electrons. And so we are going to have 4 plus 4 by 7. And that is going to give us a total number of 32 electrons. And so let's put silicon as the middle because it can make the most bonds, and the 4 chlorines. Fill in our valence electrons and see if we have anything left. So we have 6 by 4 plus 2 by 4, and that would give us 24 plus 8, which is our 32. So all of our electrons are accounted for. You can double check formal charges. Silicon is going to have 4 minus 4, giving us 0. Chlorine is going to have 7 minus 7, giving us 0. So our formal charges are all accounted for, meaning that this is the correct Lewis structure. And so now we count the steric number of our central atom, and that is going to be equal to 4 plus 0. This is bonding pairs, and this is lone pairs. And so to demonstrate that with its notation, that would be AX4. You go to your Vesper chart, go down according to the steric number 4, and go right according to the number of lone pairs. We have 0 lone pairs, so we're going to stop here, and it's going to be tetrahedral. And so if we draw that out, that is silicon in the middle with Cl, 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 and Cl. Okay, and similar to last time, these dipoles will all be equal and they will cancel out too. And so this will lead to two equal dipoles, but opposite in direction, and these will cancel to yield a net dipole of 0. And so this means that this will be again a non-polar molecule. And then we move on to our next one, which is Cl2O. We count our valence electrons. We're going to have 2 by 7 plus 6, and that is 20 electrons to mess around with. We're going to have oxygen as our central atom, and the 2 chlorines. Let's begin with one bond on each and filling in everybody's octet. So we're going to have 6, 8, 10, 12, 14, 16, 18, 20. So all of our electrons are taken care of. Let's double check on our formal charges. On oxygen, we are going to have 6 minus 2 minus 4, 0. On chlorine, we're going to have 7 minus 6 minus 1, 0. So our formal charges make sense. We have a net of 0 as expected, and we've minimized them. And our valence electrons are all taken care of. And so this is going to be our final structure. Let's go about the steric number. It is going to be the number of bonding pairs on our central atom, so 2 bonding pairs plus 2 lone pairs on our central atom, and that is going to give us the number 4. To notate how many bonding pairs and how many lone pairs, that would be AX2E2. So we're going to move on over to our VSEPR chart, go down by the steric number, so we have 4, and then right by the number of lone pairs. So it's going to be bent in its molecular geometry. And so what it will look like is going to be this. So that looks like water does. And so because of these 2 lone pairs having more repulsion than those in the bonding pairs, it's going to push these 2 angles to be greater than the optimized angle, which squishes this one and causes it to be less than the desired 109.5. And so now let's double check on our polarity. We're going to have a dipole going out that way, and then 2 dipoles going towards the lone pair. And so there's clearly a lack of symmetry here, which means these dipoles are not going to cancel out exactly as they should. There's the lack of symmetry caused by the angles, and then there's additionally the lack of symmetry caused by the magnitude of the dipoles. That depends on the difference in electronegativity. And so that is going to mean that these won't cancel, yielding a non-zero net dipole. And so that means that this is going to be a polar molecule. And that's it for this question.